Today I want to discuss Raman spectroscopic data, which is drawn between the Raman wave number and intensity. This type of curve is drawn in corrosion testing. So first of all, to draw this curve, we will collect the data from the Excel sheet. We will copy the data, Control plus Shift plus down key of the keyboard, and Control plus Shift. The data is copied, and now we can paste taking new sheet, expand the sheet, take some more columns, I need 8 more columns. Now set it as x-axis, set it this x-axis, do the same for the other columns like this. Now copy the other data, and paste it. Take another data, there are 3 data of the same test, this one, this one, this one. So I want to choose this one because this is more accurate. So Control Shift plus down key, it will select entire column, and copy and paste into the columns of the region sheet. Now take the other data, this one, Control and Shift, the down key, and paste it here. Take one more data, Control Shift plus down key or Control plus C, paste this one as well, select the entire columns, right click, plot, go to the Y offset, pay attention, we are taking Y offset and going to the stacked lines by Y offset. Click this one, we want to remove this, press the delete button, it goes. Click here again, click the line and ticks. I want to remove this these ticks, the major ticks and smaller ticks. So first of all, remove the major ticks, set here none, set here none for the minor ticks, and apply. Now I want to go grids. I want to cover all sides, so click it here and apply. Go to the vertical section, again tick here and apply. Now go to the scale, this x-axis. I don't want this portion, so I set it here 150. This part is gone, you can see here, but there are some peaks and I will analyze the peaks, but there is no space. So to make the space, I will increase this. Oh, sorry. I have cut this one area and to keep it 2000. And vertical section I can increase this, take it to 8000. Again set it 8500. The enough space is available here to write to the things, and again go to the horizontal, and I want the increment by 300. It is set by 500, so I set it 300. Now I can bold these, and I can make it 24. I can increase the thickness of these lines, set it here 1. Now it is more visible. And now write it here Raman shift. Select it, make bold it, increase the font size 28, write it intensity, take the arbitrary unit, select it, make bold it, change the font size 28 and drag it to near to the y-axis. Now I can write the name of these data. This is as received. Okay, drag it and put it here. This is normal light. These are the names of the specimens. Select it, bold it, copy and paste. I want to change it 2.5 hours. Now we want to write the wave number of these peaks, this one, this one, this one, this one, this one, and these ones. We can identify the Raman wave number of these peaks, like this is 226, 226, this is 294, this is 406, and this is 636, and this is 1310. So these wave numbers have some identification, and we will write their oxides. They represent, these peaks represent the oxides, and which kind of oxides are these we can match with their Raman wave numbers from the reference papers or literature. I have downloaded lots of literature from the internet or Google. I have this one. This paper has lots of information about the Raman wave number and oxides. These are oxides, and this is table 2, Raman wave numbers for 7 iron oxide basis proved probed in this study and given in the reference listed. These are the oxides and these are their wave numbers. These are the published wave numbers and they are references. So we will match our wave numbers, these wave numbers, corresponding wave numbers, this one from the reference wave numbers, this one and this one, and if any wave number is matched like if it is wave number set it 22 Raman wave number, suppose it is X wave number, so we can take plus or minus five or 10. If X is the wave number, then it should match with the difference of 5 or 10, or it can match exactly. I have one list of the Raman wave number and their ACM morphology and the name of the oxides, and you can see these are the Raman wave numbers or Raman spectrum, but these are not sufficient. So I have taken from the reference papers and I found lots of Raman wave numbers which can match with my wave numbers. There are lots of, and we can match ours like this one. This is 224, 224, and it should match some wave number in the reference paper. So it is matching this way. Is matching exactly, or it may be if it is not matching in the entire table and it is nearby 224, so we can select nearby, but the difference should not be more than plus minus 5 or plus minus 10. So let us take it and we will choose the corresponding oxide alpha Fe2O3, and we will write this oxide wave oxide on the peak of this graph. So we will write first of all we will drop a vertical line, and to drop a vertical line we will go to the graph and add a straight line, open dialog, so I am setting it to 225, that is the wave number. So we can choose the color of the line that has to be drawn vertically. I am taking black it here, and the type of the line, you can take solid or dash dot, dash dot, dash dot dot, short dash, short dot, short dash dot. I will take dash and will click it here. Now I will click double. Now I can increase the thickness of the line, and these are the types of the line. That if you want to put the arrow here at the beginning of the line, you can put it here. If you want to put arrow here, so you can set the arrow from here. And these are the types of the arrows. So I don't want to arrow, and but this line is going from here to there, but I want to some space. I want to reduce the length of this line. So how can I do that? So I will go to the coordinates, and there are units of this line. So I will change it to the scale. The scale of our graph. It will take the scale of our graph, this one. So I want to reduce. So what should I do? It is on the y-axis, so I have to reduce the y-axis parameter. Now it is 8500, so I have to reduce it to 7000. I will check it. Okay, it is not reducing. 6000, it is not reducing. What happened? Double click again. It is the length of this line is not reducing. It is again showing 8500. What is the problem here? The problem is here in the line parameters. There is a stretching parameter here, and there is a written whole layer. It is said that we cannot change it. So how can we change it? Set it none. If you set it none here, now you can change the length of this line. Apply, go to the coordinates. Now set to 7000. Now you can check it. It will reduce. It has been reduced. Now if you want to reduce more, you can reduce. I want to check it for 6800. Okay, it's working. You can delete it. You can write the name of the oxide, that is alpha Fe2O3, that we have seen here. the corresponding oxide is alpha Fe2O3. So we will write this on the top of the peak. So this is alpha. So how can we write the Greek letter? This is the we should click here. If we click here, so we can write any Greek letter. So I am clicking it here, and now press A. If you want to write alpha, then press A from the keyboard. It will write alpha. This alpha start from A. So press A. You can write alpha. If you want to write beta, so you can click B. You can it will write beta. So I want to write alpha, so I will click A from the keyboard. It has written alpha. Now write it, okay, click one more time, otherwise it will continue to write Greek letter. Now I am writing Fe2O3, Fe. Now take the subscript, press the subscript button here, it will go to the down, Fe2, again click it. I want to write O, again click it, 3, again click it, select the entire space, sorry, make it bold. You can change the font size, and you want to put it vertical. How can you do that? Okay, first of all I should change the font size 16, so that I will draw the other line. I will not get this sufficient space, so I am reducing the font size. Now I have to put it vertically. What should I do? Right click, go to the properties, rotate it with 90 degree. Okay, it is touching, it is going outside. I can change the range again on the vertical side. Take it 9,000. Now the problem will go. Now it is inside the graph. These has been displaced because I have made some changes. So drag them on the right place. Okay. So we'll continue. Now I want to analyze this peak. I want to know that what is the oxide for this peak. It is 294. So it should match some wave number in the reference table, and I will write the corresponding oxide. So go to the wave numbers, and this is matching with again this one. It can match any wave number, but it is matching in the same row. So I have to write again alpha Fe2O3 for the same, for the next peak. So I can copy it. I have to draw a perpendicular line or vertical line on 292. Now I can change the color because I have taken the black color for the last line. Now I will take the red color, and I don't want to a solid line, I want that it is in dash form. So okay, click OK. I want to reduce its size. I will click it 2 times and increase the thickness of the line. So again this will make the problem, it won't allow to increase the or decrease the size of the length of this line, red color line. So I have to set it on the none. Now this line can be changed, otherwise it won't change. Now go to the arrow. If you want to put arrow on any side, lower side, bottom side or top side, you can change it from here, begin and end shape. And now I want to go to the coordinate because I don't want to put any arrow. I want to take it to 6800 as I have taken earlier. Okay, I want to delete it. I have to copy this one because the oxide is the same for this line. Add text and copy. I have copied it and I want to paste it here. I want to decrease the font size. I want to keep it 16 so that I should have the sufficient space for the other oxides. Right click, select it and right click, go to the properties. Now you can rotate it and you can write it vertically. So I want to rotate it with 90 degree and OK, drag it, put it on the top of this. Okay. So similarly we can put these oxides on the top of these peaks, and we can complete the graph in this way. So this is the complete graph that I have drawn. So I have shown you only for the 2 peaks. Now you can see here for the entire all the peaks. So you can match the Raman wave number, which is matching from the reference table, and you can write the corresponding oxides on the top of these peaks. So I have written for all the peaks. I have lots of data from where you can take the wave numbers as their corresponding oxides. I have, you can see this, there is one more paper, this one. These are the oxides and these are the Raman wave numbers. Let us see other papers. Okay, this does not have. Okay, this is the same. These are some new oxides: magnetite, hematite, magmite, goethite, lapidocrosite. So these are the oxides and these are the wave numbers. So you can match from your wave numbers and you can write their corresponding oxides on the top of the on the peak of the your graph. I can show you the similar files. You can see the oxides and their corresponding Raman wave numbers. And there is one more. These are the names of the oxides and these are the wave numbers. There is one more file. These are the name of the oxides and these are the wave numbers, Raman wave numbers. Likewise, you can get lots of information from the internet of such papers where you can find the Raman wave numbers and their corresponding oxides, and you can complete your analysis through this as I have done it here. I have done already it, but to show you I have shown only 2, otherwise the size of the video will increase. I request you to subscribe my channel and press the bell icon. Thank you for watching my video. I hope that it will help you.